Thanks. All right, excited today to introduce Bob Cheripka. Bob is a senior advisor at Deloitte, working on cybersecurity. Whoop, did I just bump this off? All right, back on. He's spent 13 years in computer and network defense operations and 5 years in intelligence operations for the U.S. Army. So we're excited to have him speak to us today about advanced testing. Thanks.
Super appreciate it. Thank you. All right, good afternoon. My name is Bob Cheripka, and what we're going to be talking about this afternoon is advanced testing assessments, specifically in the power and utilities industry. To begin with, advanced testing, once you start moving beyond the normal computer network IP-based environment, starts getting very, very interesting very fast with a lot of different parameters. There's a lot of similarities that you can port across, but there are some distinct differences. So I've got two portions. Before I go into the actual presentation, a little bit who's talking today. Again, that's me. I retired out of the Army in a little bit after 21 years. Right now I'm a senior manager with Deloitte. I work in our vigilant cyber threat management. Again, went to work for Deloitte right after I retired out of the military, specifically within the Army. Started out in the field artillery, migrated to signals intelligence and some electronic warfare work, and then moved on to information operations, focusing on computer network operations. So as you alluded to, basically for about the last almost 20 years, I've been doing computer network operations in some shape or form or another. My industry experience, my main industry, what we do within Deloitte is we align our practitioners not only to a functional skill set, but also industry experience. That way you can become familiar with all the ins and outs and the understanding that goes with it. My main industry is energy and resources, specifically the power utility industry. And I also have a secondary industry in consumer and industrial products. Most of my work is doing assessments, specifically vulnerability assessments, red teaming, attack and penetration testing, the cool stuff. I get to break things and break into things. Also spend a lot of my time doing security maturity assessments. Where is the company along the line of the maturity scale in terms of their overall health and security? And I also do a lot of security operations center work, specifically focusing on the incident response, log management, and SIM implementations, which is a really nice combination coupling with the attack and pen. Because I always tell people as I bring one of our red teamer attack and penetration folks in, their security operations center should start going batty as we're doing things. If it's not, there's a conversation there has to be on how the things are tuned and how things are being detected. So it really makes it a really nice combination from both the offense and defensive side. So what we're going to talk about today, there's two parts to this presentation. One is the challenge of doing advanced testing services in the industrial control system space. We'll talk a little bit about the reasons, what's growing, what we're seeing in the environment, as well as some of the testing challenges. Again, it's a different world than a normal IP-based environment. Talk about some of the current testing approaches, and even given all those challenges, what's the need for testing? Why is this such an important issue? The second part, which is kind of a theoretical piece, is a proposed solution to how to approach this. How do we address the concerns of not only addressing the attack kill chain in that, but also the challenges of the environment? And then looking across the testing in the different zones within the ICS environment and some of the proposed challenges. And the last, we'll look at the security and legal issues that are associated with doing testing in this space and some future considerations. Please, as we go through, if you have any questions, feel free to ask. I like this to be interactive rather than just me talking for the next 40 minutes or so. So let's begin looking at the threats. What's the concern? First is the question of volume. The number of attacks that are occurring in the industrial control system space, specifically in the power utility industry, are rising dramatically. And you just have to pay attention to the news, and that kind of becomes self-evident. And we see it not only in terms of numbers, just raw numbers in order of magnitude, but also in terms of severity and potential damage. We also see it's kind of an equal opportunity employer. It affects all the sectors out there. Some are weighted more heavily than others. As you see, energy and the manufacturing make up the biggest chunk of that chart. Again, but it goes out and breaks out, and it starts affecting all the industries as well. Do you have a question?
So your electrical utilities were self-disclosing. The electrical utilities that are self-disclosing, are those numbers coming from like ICS CERT primarily, or also coming in through other sources?
Right. In fact, up here, what we actually went is across the open source vulnerability database.
Okay.
So we're incorporating a lot of that reporting into it, as well as all that self-reporting.
And is part of it now entities are getting more comfortable in reporting, whereas maybe 5 years ago they wouldn't necessarily?
It's a combination of beginning to get more comfortable with reporting, and then also the regulatory pressures to report and have to make things more public.
Okay.
So the real nice part too, and you can see the other slide again, is also from the ICS CERT as well. So again, there is a lot more reporting out there, so that gives us the ability to gather more of the information. But given that the same sources across the multiple years, you can see the up spike in that as well. And then the last part gives you kind of a flavor to see what type of events are we starting to see, what type of damage is going on, and how the things are going and being affected. The bottom line you take away from that, cybersecurity is now no longer just an IT problem. It used to be that the ICS world would say, hey, we're separated from the IT world, we don't have to worry about it. But as you build more connectivity between the two, the increased focus by the adversary on the network, the same challenges and dangers we face on the IT side of the world are starting to crawl into that non-IT space. So let's look at the environment itself. So who's out there? Where are these attackers coming from? We're seeing increased involvement by major advanced threat actors. It's not just the script kiddies out there doing it to see if they can get onto the network for fun. There's a lot of implications for nation states to be able to look in. How can I affect critical infrastructure applications, critical infrastructure capabilities to be able to affect my adversaries? So we're seeing an increased rise in that. What are they targeting? Again, as you remember that wagon wheel chart. Again, a lot of the manufacturing, a lot of power industry, but it's really starting to reach out into a large variety of industries and affecting them that way. The type of activities we see, and this is an important piece to keep away. As you read down through that, you'll see they're doing a lot of everything across the spectrum of attack. There's the technical network attacks, there's phishing, lateral movement, hitting websites. So we're really starting to see that full spectrum flavor now creep into attacks against the ICS network. What this is kind of fueled by, if you look at some of the causes on the left-hand side, some of the things that the ICS world traditionally did not have to concern themselves with directly correlates to what threats are enabled by those lacks in security controls and weaknesses in the security controls. So you can see as it's starting to come together when we talk about the environment, we're starting to get to that point where we're kind of creating the conditions for a perfect storm. Increased focus by the adversary, an industry that normally doesn't have to do this, industry that's becoming increasingly important, and then the vulnerabilities with increasingly more severe aspects as things are becoming more and more connected across the ICS space. Combined with that, from the good guy side of the coin, there are some serious challenges with testing in the ICS space. One, the way that the ICS networks now are becoming connected and expanded is happening geometrically at this point. If you think about just recent advances in even the last 5 years, all the concepts of bringing smart homes, being connected to smart grid meters. I've got homes now being power producers. I can connect my smart grid meter to my smart grid. I can control my light bulb colors with my iPhone. All these connectivity things now make that environment that the industrial control system world has to deal with expand dramatically. And that brings with it a bunch of different flavors of problems and challenges. Again, the network expanded. Most of them are not under the network of the utility company's control. The utility company does not control your smart home. They can't control how you set up your home network. They can't control how you set up your iPhone. You have increasing exposure between the different environments. Again, it used to be the ICS networks were kind of the sacred crown jewel. They were segregated. But we see increasing connectivity between the corporate business network and the ICS network. And that's, again, how you deal with smart grids and be able to affect those connectivity things. How can I link my billing to my generation and manufacturing? And how can I get my smart grid meters reporting back to my billing to streamline that process? So operational necessity is driving those environments closer and closer together. The networks are a huge hybrid and mix. You have devices on the network that are legitimately older than I am, and then you also have devices that are brand new. And then if you start paying attention to what's coming over the next horizon, next generation substations, smart grid, microgrids, distributed power generation, now I've got stuff at the complete other end of the spectrum that's all cutting edge. All that finds itself on one network all coluged together. So it creates a very, very complex environment of how do I not only work and defend in that, how do I monitor it, how do I work in that environment. Combined, we also have a high mixture of protocols, both proprietary, relay-based protocols, all the way up now to more and more IP-based protocols, as well as increasing requirements to begin monitoring and adapting and begin looking at some of these questions. A lot of changes are coming about in terms of what's required to do active vulnerability assessments. Are you all familiar with the NERC-CIP regulations that govern the power and utility industries? Now, basically, it's a big volume of regulations that govern outside. These are kind of the minimum standards that have to all electrical utilities must follow. One of the changes that came out in NERC-CIP version 5 was the requirement to do active vulnerability assessments, and depending on which criteria the substations were at, what level of testing. So there's this need to do this active testing that's coming down from the regulatory pipeline. The other challenge with this too, it's not as simple as taking the IP-based IT type testing techniques and applying it to this environment, and we'll talk more about that in a little bit. There's some very unique characteristics about these environments that you've got to adjust the testing techniques in order to get the full value out of the test. Some other challenges come operationally. We can't escape the lights have to stay on requirement. So there's a large resistance to doing active testing in this space because if you're familiar with attack and penetration testing, sometimes bad things inadvertently happen. You'll have unintended consequences. There may be a network configuration problem that nobody's aware of, that when you start doing the testing, you discover it, inadvertently locks out a bunch of users. There's this tremendous amount of resistance to that type of event within the ICS space because there's a direct correlation between the ICS network and real tangible results. It's a manufacturing line, it's the lights on, it's the water flowing. So there's that hurdle of overcoming that. And a lot of the operators view testing as only something that can potentially interrupt service. Additional challenge, our adversaries are looking at this from a full spectrum approach. They're not just looking at this, oh, I'm going to come in, try one thing and move on. They'll combine the physical with the social engineering onto the network to be able to gain access to the system. So that spectrum makes it wide variety, and that the savviness of our attackers is increasing, which then means by correlation, our testing should go to that same level of sophistication if we're truly going to be testing to keep the adversaries out of the network. We talked a little bit about the requirements, compliance requirements. There's a lot of requirements that are coming on board, and those are going to keep increasing as the networks become more connected. The final challenge that goes with the testing piece, the companies aren't magically getting more resources to do this. So you can see there's a lot more requirements, a lot more coming onto the plate, a lot more challenges associated with, but the resource pool to do the testing, both organically and as a pay-for-fee service, are not increasing with that. So now we've got, the scale is kind of tipping to that point of where do I get the resources to test from? How can I streamline this process to make it more effective? So let's take a quick look at some of the current testing approaches. Before we do that, are there any questions with some of the testing challenges or some of the kind of the environmental challenges that's facing the ICS world right now?
Have the vendors, given the threat and what NIST has been doing, have they started developing solutions that, at least for greenfield installs, mitigate some of these problems?
Part of the challenge with that is as people are starting to wake up, okay, this is a growing problem. If you think about the refresh cycle within the ICS world, it's not a fast process. Their normal cycle is, okay, the only time I'm going to replace my relay is every 30 years or so, unless it breaks. So what we're having is, how do you start now marrying that? How do I bring those new capabilities in to do this, to be able to monitor, be able to log, be able to do those things with something I'm not planning to replace for another 10 years. So it's starting to change the dynamic of that whole manufacturing refresh cycle and coming to terms with that. I attend a power utility conference every February called Distributech. And it's interesting to see where some of the technology is going in terms of what does the substation of the future look like. You know, now if you walk into a substation, you'll see a mixture of IP-based technology going all the way down to ladder logic protocols and all that. So what you'll see now is there's going to be a huge trend with the next generation substations for everything to be IP-based. Why? Because it increases the flexibility. I can manipulate it easier, I can patch it, I can change it. Of course, with that comes the associated challenges with now I'm in a more of an IP-based experience. So yes, the vendors have recognized it. How quickly it's going to go from realization to implementation is going to be the challenge. One of the other challenges with this is some of the current testing approaches. A lot of the testing approaches right now today center around configuration file reviews. We'll take the configuration file off of the machine, review it, look for flaws in the logic, flaws in the configuration, and see what we find there. We'll combine that a lot with passive traffic analysis. I'll get on the network, be able to sniff some of the traffic, and see what I can observe from the traffic. However, these two testing approaches, which are the primary two testing approaches right now that are used today, come with a lot of challenges. You know, we talked about the need to keep the lights on. That's why these two are used. If you think about this, these are pretty safe activities. There's not a lot of risk to be turning the lights off by doing either one of the activities, so that's why they're very accepted. However, if you think back a couple slides when we're talking about what's the adversary doing, you can see a huge disconnect between how do I test for phishing, how do I test for physical vulnerabilities, how do I test for compromised wirelessness. This doesn't quite answer the mail in terms of my testing capabilities I'm doing today to what the adversaries are doing to get onto the ICS networks and what the adversaries are doing through the attack chain. We talked a little bit, it doesn't do anything to identify the behavioral piece. How do I compromise that individual that might get me the initial access, either through social engineering or other means? And doesn't really address any of the emergatory regulatory requirements to do active monitoring on the network. So again, the current testing approaches today really don't do justice to what the risks and the adversaries are doing today in terms of the ICS network. So that brings us to this question. Well, if we've got all these problems, got all these challenges, what's the benefit? Why test? What do we get out of it? Well, one, we're going to be told to. The regulatory requirements are increasing and there's no going away from it. The more and more, and a lot of it was based on when they defined the requirement to do the vulnerability, the active vulnerability assessments in NERC SIP, they based it what's known as on ERC, external routable connectivity. Well, if I'm going to the next generation substation where everything is IP based, I almost have to be externally routable by default. So I'm going to increase my population of things that need to be inspected on a regular basis. So the regulations are going to drive us to have to do this active testing. The increasing connectivity geometrically increases the risk to the company, and they get it from both ends. Not only does how my corporate network connect to my production network, my ICS network, but also from the consumer end. If you start thinking about distributed power generation, I gather energy from everybody's solar panels attached to the roof of their house. I've got my iPhone connected to my smart home, connected to my smart meter, connected to my grid. So on the bottom end where I'm getting my data sources from, all that connectivity on both ends of the spectrum, increase that need, increase that risk, and I've got to have the ability to look at my network and say, how safe am I? We just talked about the number of IT systems with the environment, and they're literally talking about, again, on the next generation substation, eventually the relays will be, even down to the relay level, be going to an IP-based platform. With that said, this becomes an increasingly viable method for how to identify things that are wrong with my network before the adversary is kind enough to point them out for me. So as we look at this testing and to do this, if I can get this right and get into my network in a safe manner that doesn't disrupt operations, I can bring that same powerful IT-based tool into this world to address the same problems I'm about to inherit by all these things that are changing. And it also can be used to analyze monitoring capabilities. We were kind of joking around at the start of the class. If I bring my red team in and my security monitoring team from the client's not screaming bloody murder when I'm doing my stuff, there's a disconnect between what the monitors can see and what's actually happening on the network. And that becomes very, very important as you start bringing in these multiple environments and all these different seams that the adversary can run along. How do I get into that to monitor that? And I can use my testing to help flip around and tune that. The other component of it is our ability to see into attack. If you look at both the corporate side and the IoT environment, when the adversary does things, they create an observable footprint. We just have to know to look for the right pieces of it. So if you look at it, we have a lot of our testing methodologies that mimic a lot of these actions that let us go in and find those things, find those observable actions, as well as then be able to use that to help tune our security monitoring capability to look for those same type of things. Right now, today, that's a hole in that armor there. How do I provide that same methodology and same rigor into the ICS space amidst all these changes, amidst all these challenges? So how do we test? First, we can't ignore the operational concerns. We're not going to get away from that, the lights have to stay on requirement. So we have to be able to tune our security argument and security discussion to put it in the operator's terms of saying, how do I test and alleviate that concern? We have to be able to incorporate those emerging regulatory requirements. Again, when we do our testing requirements, we don't want to have to test once for security and once for compliance. I should be able to come, the running commentary is when we do a lot of work. I should be compliant in terms of the regulations by the fact that I come in and do my job in an operationally secure manner, that the two should overlap. That way we reduce the exposure to the network and also the amount of time you put the network at operational risk. We have to be ready to incorporate emerging technologies while still addressing those legacy systems. We're going to be living in that hybrid world for quite a while. So the model that we're going to use for testing has to be able to adapt to both environments, both addressing the legacy systems and then dealing with the new emerging technology. We have to move beyond the restrictive testing technologies that exist today. We can't afford to sit there and say, okay, a passive traffic analysis with a configuration file is good enough. So we're going to have to kind of push the envelope a little bit, but while incorporating the challenges from above. You also have to realize too, most of the companies and folks that are in this business don't have a robust testing lab. They don't have a robust facility where they can do a lot of this on their own. If you think about it, setting up a lab and maintaining a lab is an expensive operation. If I'm a company worried about generating profits and revenues and all that type of stuff, and I've got an operating budget to keep the lights on, that's kind of a lab is kind of a sunk cost for me. I don't necessarily get a quick return on investment. So you're not going to see organizations being able to absorb that and do it effectively on their own. So, yes.
So as part of the support from Deloitte, do you have better metrics to help corporations understand this is your risk, this is your consequence, this is what it costs to avoid the consequence,
Yes.
this is the cost if you don't avoid the consequence?
Yes. In fact, one of the things we do right now, especially on the assessment side of life, and I've done this a lot when especially you talk about the security monitoring, the log monitoring capabilities, we'll go in, we'll do those type of assessments to say, okay, with the correlation rules that are running through the SEM and what you're monitoring, how well does that align to your risk posture, the behaviors you want to observe? This is what it'll cost to fix it and adjust it as well. One of the things that as you look at this, and again, while the configuration reviews and the passive traffic will reveal some stuff, it really doesn't scale up to the order of magnitude of identifying what's the rest of the story in terms of the vulnerabilities we haven't discovered. You can still do, and get those updated and fixed. Did that answer your question?
It does. Are you finding the C-suite is now looking at this more as a risk issue than maybe a few years ago?
there is a growing concern, realization that this is a growing concern. In fact, I'm not 100% sure the C-suite's aware of it in terms of the order of magnitude. This is really important, and then they've got that part of it. And especially when you talk to their vulnerability management and their security controls folks, we start talking about a lot of this how do I get in there and assessment? And the most common thing I've heard is, hey, if I can do an active vulnerability assessment against my IP-based ICS things, or demonstrate through a red team how you can go from the internet all the way down to a substation, that's a gold nugget for me. That's an important capability for me to develop. So the realization that this is important is definitely there across the board. The struggle becomes okay, understanding it's important, how do we implement it in a manner that's effective without causing damage to the production either power or whatever other ICS system we're running with. Okay? So what I want to do now is, now that we've kind of covered the risks and kind of the background to this, is kind of take you into this is a proposed piece we're working right now and kind of developing out that's kind of built on our existing attack and penetration testing methodologies, and saying how do you port that robustness and rigor into the ICS space. So the first part is we begin to look at this as a holistic environmental problem. We've got to be able to test across the entire environment. So at the first level, you have your corporate, your business zone, and your corporate zone. This is normal IP-based normal IP-based testing as exists today. This is the corporate network. This is the business network. This is how they move all the human resource information around and those type of things. So nothing really changes in networks because we do that and we're capable of doing that today. Then we started moving down the stack and began to look at the demilitarized zone, that border where the two worlds touch. Within that world, we looked at it and said, there's still a lot we can bring our methodology over, because a lot of the devices in that world are still very much IP-based. The challenge becomes is, how do I do it in a safe manner that I don't disrupt operations? So what we're looking at doing right now, what I've kind of put in quotes and tentatively calling our replication environment, is the lab construct between one or multiple labs to be able to say, how can I bring client information into one of these labs using real world information, test it in the safe lab space, and provide the results in an effective manner. So what that lets me do is still bring in real world live information, bring those robust test capabilities onto that platform, test it hard, and then provide back to that piece. That applies really well in the DMZ zone, because again, most things in the DMZ zone are IP-based. Going down at the operation zones, now we're starting to get into the substation. We're starting to see those mixture of protocols. Again, the model keeps porting down. We'll bring the testing methodologies and apply them where they apply. Still want to have that replication environment where we can use the created lab to go ahead and test in this environment. But then also what we're going to do is add custom diagnostics at this point that bring in and begin testing the legacy protocols. So now we're kind of creating a hybrid model between the normal IP-based testing methodologies and customized diagnostics that specifically address that lower tier of the stack. So as you look through all three, I now have a process and methodology and a thought process. I can test from the top, where I touch the internet, all the way down to the bottom of the substation. We'll go through this in a little more detail as we go through. But the key to making this successful is the creation of those lab environments where you can create that safe testing environment that the companies and corporations can't create themselves. One of the things we looked at, we then took a step back and said, if I look at all three of those three stages of that process, does it address the cyber attack chain in a much more complete manner? And the answer to that question yes, it does. I now have the ability to test robustly across the kill chain, across the entire environment. We also looked, does it apply across the entire environment well? We looked at tailoring the approach to each leg of that requirement with each environment level. Tried to maximize the use of IT testing techniques to the maximum extent possible. And again, as we talked about the substation of the future, things going more IP-based, you can see those IP-based testing methodologies are become more and more applicable as we go on through the process. We start tailoring things to the use of the proprietary and lower level protocols. and begins that testing infrastructure to reduce that risk. So we didn't ignore the question or ignore the challenge from the operational side, say, hey, the lights have to stay on. We said, let's take a step back and how can we adapt our methodology to a safe environment where we could actually go in and do this. And then it could be applied for either security or regulatory requirements. So it kind of answers the mail for both requirements of which is driving that. So diving down a little deeper, again, the business zone, nothing really changes. This is our normal attack IP-based methodology composed of diagnostics, vulnerability, attack and penetration, all the way up to red teaming assessments. That's the stuff we do every day for all our clients. So we've got established track-proven methodologies that let us test robustly on that corporate level of that network space across all those different testing regions. So again, we started on that, using that as a foundation to build up. Within the DMZ zone, we're going to start with, the methodologies, because again, most of the technology within the DMZ zone is still very much IP-based focus, What then we looked at is how do we create a process in the environment to be able to go in, replicate that client network portion, have a methodology for gathering it, implementing it, and then tearing it down and providing the results back to the client. So that's the part that we're in the development mode right now, and working to build that out. What now that it gives us a way, though, is to take those IP robust methodologies, apply them in safety to that IP-based zone that before the client wasn't really necessarily willing to let us touch because of the concern of the operational impact. Taking it down a step even further, again, we're going to continue to build on the stack, build with our methodologies, bring that replication environment in as well. Again, if you look at a substation, there's kind of a cut line through the substation of where IP-based technologies start and stop. Above the line, again, very, very similar to the normal IT environment. Below the line, you start getting into all those protocols. For those protocols and those pieces, we've started developing a bunch of diagnostic services that really focus on getting down to the nitnoid detail about that type of technology. Yes?
So just to make sure I'm getting this right, so what you're saying is you create offline a virtual lab, if
Correct.
you will, and then based on that and proving that it's robust enough
Right.
and safe enough, then you can go to the client and say, this is now ready for prime time. Let's check out your system in reality.
Right, and actually we're going to even take that a step further with the use of the lab, is not just demonstrate that it's safe, because there'll still be that, you still want to eliminate that risk of damage to the actual production network. But imagine being able to go in to the client's network using the virtual technology, effectively clone their network, bring that clone over to the lab in total, bring it back to life, and now I test in that virtual environment. So there's some pieces there that we doing work with too, is how do you get into testing those virtual images and adapting those methodologies? Because remember I said that it doesn't port over directly, and you have to modify some things. There are differences between testing in the virtual environment and testing in a physical run. The results will be the same, but what we're doing is by bringing over those virtual images, now we're bringing real world data. My virtual image, how my HMI functions within that virtual environment is going to be a mirror copy of how it functioned in the real world, because I've ported that all over the best I can. So what we're doing is actually creating a clone of the network, bring it over to a new environment, test in that safe environment, and then funneling the results back out. And then merging that with a lot of the diagnostics. Now, as you bring in the next generation substation, things become more and more IP-based, what you'll see happening is a lot of these focused diagnostics, that group is going to get smaller and smaller, because we'll be able to test more and more down. At some point in the future, we're not going to need to have to test programmable logic, because the relays are going to be IP-based. So one of the things we did is we have to look at this from the perspective of how do I begin looking at this? How to ensure completeness within the testing model? So we started saying, what portion is covered by our diagnostic services? And that's down at the bottom of the stack today. What portion would be covered by that we could do in the replication environment? And you see, we're able to cover almost the entire top level of that substation control room in that replication environment by being able to port that over. And we get a nice picture of what we're able to cover So really, with the exception of what's out physically in the switch yard, is what we really exclude from the testing. The key thing with this too is, unlike a configuration review where I'm going in and looking just how a device is configured, this also lets us be able to test how that one device talks to another device, because I'm replicating the environment in that, or replicating the substation in that environment. I can see how the effects, if I affected one device, what's the ripple effect throughout the device? Can I affect a relay by doing this device? If I compromise this device, what can I do to the stack? So we're getting that realism back into the testing, much in the same way the adversary. The other piece is if you think about it, at the bottom of my lab setup, if I start adding distribution emulators to the bottom, I can then even take that a step further and saying, how can I attack the top end and demonstrate a realistic effect on the distribution level at the bottom, and really demonstrate this is why it's important, because you see I can directly control and affect power. So this has a lot of implications as a concept and a lot of abilities to grow and get into a much bigger effort. So what we did is we used a real-world substation to model off of, gathered the equipment and stuff like that to use as the foundation for the lab, and then began looking at applying the same approach. Where can we test? At the IP-based level, replicating all the boxes in red are things we can replicate right now today through VM technology. The other pieces get covered by the focused diagnostics, and again, as technology will go, as these become more IP-based, the red blocks will become more and more prevalent throughout the base. So we're patterning the lab off of a real-world substation. The beauty of doing this in a virtualized manner is while I'm using this particular substation as a model, I can effectively do, once we've got the pattern established and the processes worked out, I can literally do this for any substation in the world. It's just a question of gathering, building, bringing up the virtual images and building the links. Any questions on that part? Okay. Real quick, as we look through this, there's also some specific security and legal considerations that we have to take in consideration as we do this. We may be dealing with NERC SIP data. We may have to take special measures to safeguard that data, much like we do today in a non-testing environment. So as we develop the methodology and process, part of how we gather the data, how we gather the configurations, how we store them, how we transport them, all have to be taken in consideration to make sure we don't create a compliance issue by trying to do the right things in testing. They may be considered client proprietary. The client may say we have the design of our substation is proprietary. We don't want other folks knowing what we've got out there. Again, how do we safeguard that data to prevent that from being disclosed? You may wind up with sensitive data involved in that. We're talking configuration data. We may inadvertently get, or not inadvertently, but we may wind up access to username and passwords within that configurations. And again, we talked about how you transfer and transport that and secure it, especially not only while in motion, but also while it's at rest. So a couple things for the future. Okay. We do need to pursue this as an aggressive effort. As you saw from the beginning, there's a huge disconnect between what's being done today to test in this space and what the need is in this space. And the clock is ticking. As you look at what's coming down the pipeline, microgrids, distributed generation, Internet of Things, all the smart grid meter stuff, the problem is going to keep getting larger and it needs to be addressed quickly. We do need to take those operational considerations in our approach. We can't just say you have to do it and accept the risk. Just think of any time you see the lights go off for any time, extended period of time, what happens? People start looting, get concerned, causes panic. So we can't have our testing be doing a disruption of service and doing the right thing. So we've got to find a way to work with those operational concerns in our approach. We have to live in the real world. We can't limit ourselves to the static configuration file as a point-in-time event because the adversaries are adapting. They're changing their attack techniques to be able to get into these different substations and different power grids. So our techniques have got to mirror that and live in that world of real world data to provide real world results. And we have to make this so this is adaptable to emerging security programs. If we continue to have this as a challenging problem where it's too hard to do, it's never going to get done. Our running joke in the security world, the security has to be transparent to the operational function, and then it gets done. If you can't get to that bar, and that's a pretty high bar, 9 times out of 10, when it comes to the choice between operations and security, security takes the back burner. So, and we need to incorporate the emerging technologies as well as the requirements to use this as an opportunity to get ahead of the curve. If you think about the implications of what a next generation substation, when everything's IP based, means in terms of security, in terms of risk, the time to start addressing that problem is not when I have 10 of them implemented already. The time is now to start thinking, how do I structure myself to get ahead of the power curve where I'm ready to test, I'm ready to evolve to that. So as those start being implemented and they start replacing things, I'm ready to go ahead and roll right into that.
So I think I'm starting to get what you mean by IP-based. So you're saying that the logic that was normally done by like an RTU or a PLC at the substation is now being moved to where the control room is. Is that what you're saying?
They'll be able to do that. So what's traditionally, right now in a relay, you'll have the programmable logic controllers down at that level, and it's kind of a standalone hard device. What we're seeing now is like one of the things I did when I was at Distributech last year. I spent a lot of time looking at what are some of the substation designs of the future, and it's very much getting down where even the relays are going to be IP-based Windows, Linux operating system type devices. So we're going to see that pushed all the way down through the stack. Volumes of data is also going to grow by an order of magnitude to bring that. So this allows us to kind of start getting ahead of that curve and say, okay, I'm ready to test safely in that world before that world really exists.
So how do they cope with loss of communications if they're trying to control a substation remotely when they don't have the PLC acting in an isolated fashion on its own?
Right, they're going to have to address the redundant communications problem with that as well as they make that move. And that's why a lot of power stations say they don't have that external routable connectivity, because to be honest, it's not worth the headache of trying to do it now, because I still can't reach half of my stuff. I think we're going to see, again, that's my opinion, I think we're going to see that shift, because if you think about it, if I can reach down and manipulate my relay from my control station in a very efficient manner, and it can tell me a lot more data coming in, I gain a huge operational benefit to being able to do that. I'm going to want to do it more. And that's the whole premise behind the redesign of the substations and moving to that new substation. And then as we see that comes in, of course, now all the traditional problems you have on an IP-based network come right along with it. But now we have a different environment with a different set of rules that we have to begin to be able to ready to address, different from our corporate network. And that's where, if you think about back to what I was saying, you can't just take the IP-based IT testing principles and slap it on this world, give ourselves a high five and call it done. It still has to evolve and be custom tailored to the challenges within this space, because it's a little bit different animal still. So it's a really fascinating problem. It's a challenging problem. And I think that takes me to the end. So I will open up the floor for any questions. Again, a lot of this has involved some heavy lifting and development in the labs and putting that together. So we're rapidly moving before this. A lot of this is still what we call the point of view level and concept level of presentation. And so there's still a little bit of work to get done before is this ready to kind of take it to the client to get to say, okay, we're ready to actually do this.
Yeah, so from my understanding is the client would have to view their infrastructure and perhaps the data to you so that you can simulate a model for the environment, right?
Well, not necessarily them providing, we would go in and work with them. Because if you go back to the operations zone model, where that one PowerPoint slide, part of that process is how do we do that effectively, going in an organized fashion, work with the client to gather that data, properly safeguard it, bring it up in the replication environment, and then of course, just as importantly, tear it back down in a safe and controlled manner that still safeguards that data. So that'll be a joint effort between us and the client as a concept.
So I'm just curious, how often do organizations give up information like that? Because it seems to be very proprietary at times.
Well, in fact, in some ways it's similar to what they do today. If you think about the configuration reviews, when I give you my configuration file for you to perform the review on, I'm giving you effectively some of that similar information. On the IP base, on the corporate networks, we do it all the time. We let people into our corporate network, you can review the data and all that. So I don't think that's going to be a hard mental transition to say the same thing we do on your corporate network in viewing your data and safeguarding it is the same thing we're not going to do in this space. So I think there's a lot of parallels between that. So I don't think we're going to encounter a lot of resistance in that regard. I think the major concern that the clients have is we've seen instances in the past where doing normal testing on a normal corporate network has unintended consequences. I can't live with unintended consequences on my ICS network that could potentially turn the lights off and affect power generation. I think that's the bigger hurdle to overcome. Any other questions? Well, super. I hope you all enjoyed the talk. Again, we've got a lot of work to help get this from where we are today to an actual viable testing program, but the thoughts are there. And that's really what this was, to kind of get the brain juices flowing, get the thoughts flowing of where do we need to take our testing capabilities and our resources and maybe looking toward the future, so when the next generation substation comes online, we're there with a viable testing methodology saying we can address these concerns, we can address your regulatory requirements, and oh, by the way, we're not going to turn the lights off. Thank you very much.
Thanks.